Hi everyone, today we are going to look at architecting at scale, how I delivered a microservices platform for a large enterprise. The legacy platform we inherited was a monolithic Java application with a single code base, large WAR files, and shared persistence across modules. This made even small changes risky and slowed down release velocity dramatically. Teams were blocked by each other's dependencies. A change in one module required coordination across the entire system, leading to bottlenecks, regression bugs, and production delays. As user volume grew, batch processing workloads started to fail intermittently. Response times deteriorated during peak hours. Scaling vertically became expensive and hit diminishing returns. Business stakeholders were frustrated. They needed new features in weeks, but the release pipeline could only support one monolithic deployment per quarter. We identified an opportunity to re-architect the platform as a set of microservices, enabling domain ownership, independent releases, faster development cycles, and horizontal scalability. We started by identifying bounded context using domain-driven design. This allowed us to define microservices with well-scoped responsibilities such as audit logging, user management, rule execution, and alert handling. Each microservice was implemented in Java 17 using Spring Boot 3, exposing RESTful APIs with OpenAPI Swagger documentation. This made onboarding faster and ensured consistent contract first development across teams. We integrated Apache Kafka for asynchronous communication between services, especially where event-driven patterns made sense, like transaction logs and real-time rule evaluations. All services were containerized using Docker, and we've deployed them on AWS EKS, Elastic Kubernetes Service, with Helm charts. This gave us full control over auto scaling, health checks, and blue-green deployments. For persistence, we used PostgreSQL as the primary OLTP database. With read replicas across regions. Legacy modules that still needed Oracle were wrapped with API facades for compatibility, minimizing disruption. We organized teams into agile squads with clear service ownership, running bi-weekly sprints, backlog grooming, and cross-squad syncs. Jira was used for sprint management and Confluence for documenting architectural decisions and retrospectives. Our CI pipelines were powered by GitHub Actions. Running code compilation, linting, static analysis, and unit test on every pull request. We enforced branch protection rules and quality gates using SonarQube. Jenkins handled our multi-stage CD pipelines, which included build artifact promotion, environment-specific configuration, injection via Helm, and approval workflows for production deployment. Testing was a top priority. JUnit 5 and Mockito were used extensively for backend unit tests. Contract testing via Spring Cloud Contract validated API compatibility between services, and front-end testing used Jest and React testing library. Observability was integrated from the ground up. Logs were shipped to an ELK, Elasticsearch, Logstash, Kibana stack. Metrics were captured using Prometheus and visualized in Grafana dashboard for latency, error rates, and throughput. Outcomes and measurable impact. We completed the re-architecture and deployment of the new microservices platform in under 10 months, with all MVP functionality delivered and signed off by product and compliance stakeholders. Deployment frequency tripled from once every quarter to multiple times per week. This was made possible by independent CI/CD pipelines, and loose coupling between services. Our new Kubernetes-based infrastructure with proper health checks and retries achieved 99.99% uptime with zero serve-1 incidents reported post-launch across 3 quarters. By redesigning critical service paths using async Kafka flows and removing blocking operations, we reduced average API latency by 30% even under heavy transactional loads. Teams that previously waited on centralized release cycles could now develop and release independently, improving velocity and ownership. We saw 60% improvement in feature throughput within the first 6 months of migration. Modeling domains correctly is the foundation of microservices success. Start with clear boundaries. Each service should map to a specific business capability, not just a database table or UI component. Automation is your best friend. Invest early in robust CI/CD workflows, testing strategies, and gated approvals. Multi-steps in modern delivery pipelines create risk and bottlenecks. Failure is a first-class citizen. In a distributed system, you must design for retries, circuit breakers, fallbacks, and degraded modes. Testing helps, chaos testing helps validate production resilience. Observability is critical for running microservices in production. You need real-time visibility into logs, metrics, traces, and alerts, or you're flying blind during incidents. Architectures should enable business agility. Our success wasn't just in deploying modern tech, it was in creating a system where teams could move faster, safer, with more confidence than ever before.